Derivatives: power, constant, and some difference. AP Physics C uses calculus as a tool to solve problems. The specific tools you will need are outlined in this presentation. A full explanation of how those tools were developed and how they are generally used is beyond the scope of this course. For that, you should study PMI AP Calculus. Also, the examples that show how those tools are useful in physics will come during the course, so are not repeated in this refresher. This guide is to help students in the use of these tools. Overview. The derivative of a function allows us to find its slope at any point. By then putting in the coordinates of a point, its slope at that point is determined. The slope of a function has great usefulness, which you will see throughout this course. Finding it requires learning a few rules and how to apply them. Notation. You may see many different notations for the derivative of a function. Although they look different and are read differently, they still refer to the same concept. Here's the notations, and here's how they're read. So this would be f prime of x. This is y prime. This is the derivative of y with respect to x. And this is the derivative with respect to x of f of x. Here is the power rule, which is a very quick and easy way to find the derivative of a function. So if your original function is f of x equals x to the n, f prime of that function, the derivative of this function over here, would be n times x n minus 1. So you take this power, you move it into the front, multiply it by the variable, and then subtract 1. So for example, if f of x equals x to the fifth, then f prime of x equals 5 times x to the fourth. So you just take this 5, you put it down front, and then you subtract 1, and you're left with a 4 up here. Here's another example. Your original function has a constant in front of it here. So up here we just had a 1 in front of the x. But here we have c. So what you're going to do if you're going to take the derivative of this function, you take this n, you multiply it by whatever is already in front, so c times n, and then you still are left with n minus 1 as the exponent. So for example, 2x to the 6th power, to take the derivative of that, you take the 6, you multiply it by 2, and that gives you 12, and then you subtract 1 from 6, and you have the 5th power. The constant rule. All of these functions have the same derivative, which is 0. Why do you think this is? Think of the meaning of a derivative and how it applies to the graph of each of these functions. Discuss. So if we have a function equals c, where c is a constant, the derivative of that function is 0. Well, as we learned before, the derivative of a function helps you calculate the slope at any point. So if you take a graph of y equals 2, it would just look like a horizontal line like that, and the slope at any point on this line is 0. So that would be one way to figure out that the derivative of a constant is 0. Another way is looking at the power rule. So if we had a function equal to x to the first power, which is just x, if you did the power rule here, you would take that 1, put it in the front, so you would have 1x to the 0 power. That would just become 1, so you'd be left with 1. But imagine your function was f of x equals 2, which is essentially this one. Well, that could also be written, 2 is the same thing as 2 times x to the 0, because x to the 0 is just 1, so it's like this can be there if you want it to. And if you did the power rule here, 0 times 2, that would just give you 0. So using the power rule, you can see why a constant has the derivative of 0. The sum and difference rule. All right, so if your function is an addition or subtraction of two separate functions, then your derivative of your main function will be the derivative of each of those functions added or subtracted together. For example, if y equals 2x cubed minus 5x squared, just take the derivative of each portion and keep that negative sign. So we have 2x cubed, which becomes, the derivative here becomes 6x squared. Then we have 5x squared, and take the derivative of that, and that becomes 10x to the first power, and we still have our subtraction sign. Here we have another example. y equals 4x to the fifth plus 3x, so we just take the derivative of this first part, which would be 5 times 4, which is 20, times x to the fourth, and then we add, and then take the derivative of the second part, 3x. The derivative of 3x to the first power is 1 times 3, which gives you 3, times x to the 0, which is just 1.